second. And we don't need any premises, that's just going to be provable from nothing. Now, you'll notice that I wrote a shortcut here, which we also used in 101, which is not equals. That means not equals. So it's a negated connective, this one. So you can use negation, introduction, and elimination on it. You can think of that as not x equals y, if you prefer. Not equals literally means not equals. Okay, so this whole thing, it's a universal. We unpack the universal for all y if a and not if y implies a is not y. I'm leaving out the justifications on the right hand side. Why? Because that's the edge of my page. Feel free to put them in. We're not doing anything complicated with them. There's the universals. Here's another universal. If A and not if B implies A is not equal to B. And just for fun, I've changed the connector to a not there. This is the same thing. A is not equal to, not A is equal to. Now this is overall as an arrow. We know what to do with arrows. If A and not if B, and we're trying to prove not A equals B. So, we've got a conjunction, we could unpack that. We've got a negation, we can always do that negation first. This is like an optional rule, this is one which is a high priority. How do we unpack that? We assume A equals B, and we try to prove a contradiction. That's what the negated A implies B means. And we definitely run out of room now. 6 to 7, negation introduction. So, in that line, I will write small. F of A, that comes from 4. F of B, that comes from A, I'm using the A equals B. You're going to get not F of B here, also from 4. So now I have F of B and not F of B, and bang. Small explosion. So our assumption that A equals B must be false.
Excuse me, hello. On the first line? No, from bottom up. So you have, at the end you have not x equals y, right?
Yeah, not x equals y, which is the same as not x equals y. Yep.
Okay.
So here I'm changing the x to A to B, and here I'm just changing the symbol. This is just a different way of writing the same thing.
Right. Okay.
It's just easier to notice here you need to unpack the negation when it's broken out like this rather than that.
Okay.
So that's why I was getting close to that, I just changed my notation. And this bit in between is the equals from 8, 10, 6, and 8. And I'm writing that out because that's our new rule. We took our f of A and our A equals B and changed it to f of B. But also we knew that not FB. That was our contradiction. So apart from the equals, it's reasonably simple, standard in K, and we're using identity to do stuff. Who feels they've kind of got the hang of this and can do one for themselves? Yay, all of us. Right. This is good. You're all buzzing with enthusiasm. Right. So, let's suppose that we've got two things, and we've learnt they're the same. Oops, no. Now you can see what I'm writing. We've got, so if they're the same, then, so we've got two things, we've learnt they're the same, then, do we know they're frogs? No, we don't know that they're frogs. But hey, if one of them's a frog, they're both dark, because it's the same thing, right? If I talk about the stage manager of the Muppets, and I talk about Kermit, hey, they're the same person, it's either they're both frogs or neither of them are frogs. So, the first one's a frog, and the second one's a frog, and the second one's a frog, the first one's a frog. We know that why? Because they're both the same thing. If they're the same thing, then they're both frogs or neither of them are frogs. this seems to work with Muppets. Prove it in general. I'll give you a couple of minutes head start. We'll be unpacking this and this and this. Probably this double-headed arrow, just doing standard unpacking rules. And only be a couple of steps where you need the equals. You should be able to do the whole thing in about 9 lines, apparently. Of course, left myself 6. I'm just unpacking my introduction of my double-headed arrow now. So I've just unpacked my 2 quantifiers, my arrow, my implication, and my biimplication. So that gives me this structure here, just by doing those 4 rules. And now somehow I need to prove f of b, and all I know is that f of a and a equals b. And I need to prove f of a when all I know that f of b and that a equals b. Now once we get to that stage, that should be straightforward. To unpack, it can be a simple application of our identity rules. F of a, but we can change a into b. So by 5 and 6, we've done this. But f of b, we can change our b's into a's. So by 8 and 5, we get f of a. So unpack almost all the structure, we only need 1 or 2 identity rules for that. So far we haven't done much with identity except like the last step, right? So it seems reasonably harmless, but you know not to trust me. It does get more interesting. So I'll check whether you guys are comfortable and whether we can move on to the so-called interesting ones, or whether we want to stick to the solid stuff that we've got now for the next little while. The second half will get more complicated. Okay. So I know NK is a bit rusty. You can practice a bit.